So I'm gonna go question number 69. 69. So they give us integral and they say 4 to 9 and they give us ln of y. So what I'm gonna do, I'm gonna separate because I know this is gonna be by part. And then dy. So what I'm gonna do, let me reciprocate. So this is gonna say integral 4 to 9, 4 to 9, and this is gonna be y a half, negative a half. Take it to the top, and this is ln of y dy. So from by part integral, our integral u dv equal to uv integral v du. Okay, so what is our u? Our dv, our u is going to be ln. Whenever we have a ln of something, that's going to be your u. So I'm going to say let u equal to ln of y. So du equal to, when you integrate, this is going to be 1 over y dy. Okay? Now dv equal to the other one, which is going to be y a half, negative a half d dy. You see what I'm saying? Whenever you have a ln, you let it equal to. Okay, now integrate. This is going to be integrate this side and this side is going to be equal to. You just add by 1. Okay, add by 1 is going to be y positive a half, which is square root of a half, and then divided by half, which is 2, is going to come there. That's all. So we got u and v. So now in substitute right there. When you substitute, this is going to give us the integral of that 4 to 9 1 square root of y ln of y dy equal to uv. uv is going to be 2 square root of y ln of y integral v. V equal to 2 square root of y. So say 2 square root of y, and then du 1 over y, and then dy. So we can put these together. Okay, so it's like y a half over y. This let me say y negative a half. Y negative a half. Yeah, y negative a half. And then we can add 1 when you integrate. Okay, so this one here is like integral of y negative a half. So when you integrate, means we add 1 to the top, add 1, and then also add 1, same thing at the bottom, which is going to be a half. So y a half and 2. So after we integrate this, it's going to give us y 2 y a half. Okay, 2 y a half, and this 2 is going to give us 4 because there's a 2 here. It's going to be 4 square root of y. 4 square root of y. So all this half is going to give us 4 square root of y. 4 square root of y, and then we plus, no, we don't have a constant. We're going to have to put our limit here. Limit, lower limit, and upper limit. So since this is a definite integral, means you have to take upper limit, substitute all throughout, and then minus lower limit. So this is going to be 2 y. What is a y? Y equal to 9, and the ln of 9 also, then minus 4 square root of 9. Take this 9, substitute here, whenever there's a y, and then minus, take the lower limit, substitute throughout this expression. So you say minus, and then substitute with the lower limit, which is 2 square root of 4, and then this is going to give us ln of 4 minus 4, and then 4. Put this in the calculator, I'm going to get 7 value. This is 2 times 3 equal to 6 ln of 9. Ln of 9 minus, if you want, you can simplify this one. You can say, okay, 93 squared, so it's going to be 3 square, bring it to the back, so 6 times 2 equal to 12, and then you minus 4, this is going to be 3, which is going to give us 12. This is going to give us 12, and then you minus, okay, this is 2 times 2 equal to 4, because this is 2. 4, and then 2, this is going to be 2 square, 8. It's going to give us 8 ln of 2, and then minus 4 times 2, because this is 2, is going to be equal to 8. Okay, so you can put this together, and then that's all. So you can say, okay, 12. After you can finish here, and then it's fine. Put in a calculator, simplify, and then you can get it, because this is going to be negative 12 plus 80, negative 4. So for the numbers, it's going to be negative 4, and then you take this one together, 12 ln of 3 minus 8 ln of 2. That's all. You see what I'm saying? So we're done with this question, now we go to the next one. So question number 70. Okay, question 70. Question 70 now. Okay, let's go to question 70 now. As far as you see, this is also by parts, because I have a ln and there's nothing here. So I'm going to say this is going to be u and this is going to be L dv. So it's an integral of u dv equal to uv minus v du. Okay, let u equal to ln of 2x plus 1. Okay, differentiate du equal to, okay, this one we know. We have to differentiate the function, which is going to give it to over exactly what I have to give to you. because this is a ln of a function, okay? And then dx. It's like somebody give ln of a function. If you differentiate, this is going to give you function derivative and then over function given here, which is this one here. So derivative whatever you have, and then, so just like here, derivative this, you get 2 right over exactly. Okay, now, dv equal to dx. So when you integrate is going to be equal to x. Okay, now, so we got everything. So substitute in the equation. So now we say integral of u dv, which is this one, integral of ln of 2x plus 1 dx equal to uv. What is a u? U equal to this one times v. So I'd rather start with the x. Ln always come after everything. That's a good way. Don't write times x because it's going to look like they are together, which is not right. So better write like this. Something in the ln minus integral v. V equal to x times du. Our du equal to this one, which is 2 over 2x plus 1. And then dx. These 2 can go to the back, which is going to be 2. And then, okay. This one here, how are we going to do it? Okay, so we got x. Okay. V dv equal to 2 take to the back. So now we have this one. How are we going to conquer this one? Okay. Okay, just a second. How are we going to go for this one? Which method I can use for this one? Just a second. Is this a question? Okay, but okay, cool. Let's go here for so long. Just an example. We don't want it to a lot of time. So ln 2x plus 1 and then minus these. How are we gonna solve this? Okay. Okay. X plus 1. I'm gonna solve that. It's crazy. Okay. 2x. Okay. So maybe somebody can remember. Okay, so you get 2 and then integral of that. How I'm gonna do, because I cannot do substitution. If I substitute this was go, maybe I can just do by okay, let's say x. Okay, divide by 2x plus 1. X divided by x, you get x divided by 2x. You get a half. Yeah, you get a half. A half times 2x you get equal to, okay, half times 2x equal to x. So give us x, yes. And then you say a half times 1 equal to a half. If we subtract this, it's going to give us nothing. Negative what? Negative a half. So if I take this divided by this, it's going to give me a half. I want to do like a partial fraction. Plus, left to the negative a half over everything, which is what is 2x plus 1. Yeah, so I can do something like this. So I can separate these two. Oh yes, I'll do like that. It's personal, right? But somebody could have done the method. So say 2, and then this integral is going to be integral of a half dx, and then minus. But I think if somebody watch this video, you can tell me what is your opinion on this. Okay, it's simple, but I don't know how. Okay, now negative half is going to go back. So negative half is going to go back. Okay. Oh, plus and minus. So I don't need negative again because it's supposed to be. Okay, a half plus and minus, and then this a half, and there's an integral of 1. Because like if you take this one divided by that, instead of writing that, we get a half, which is a half, plus negative a half, which is the remainder over everything. So now replace all of these with these two. That's to say a half here, and then dx, and then I go my negative a half, and then 1 over 2x, 1 over 2x plus 1. Very interesting question, this one. Okay, plus 1. So now we don't need this. Okay, I don't need that. Okay, I don't need that one. And I'm gonna say, okay, plus 1 dx. Okay, now the question is finished because this is gonna be x ln 2x plus 1, and then minus 2. Okay, Okay, let's do 2 in the, okay, 2 and 2, 1. 2 and 2, 1. Negative plus. So now I'm not gonna have a 2 anymore. And when you integrate these dx, you get x, and then no bracket anymore. Negative is gonna be plus. This and this is gonna be just a 1. Okay, this is gonna be ln. It's gonna be 1 over 2 ln of 2x plus 1. Yes, I'm sure, boy. Okay. Yeah, cool. So this is what we got. So if you integrate this, that's what we have. Okay. So this is your final answer. Okay. That's our final answer, and this is ln here. Let me write clear. So that's my final answer. I'm gonna have to write this question aside, just that part, just in case later I wanna reach it, if I did right or wrong, especially that part of integral of x to x plus 1 dx. Okay. So I say they have. I want to check, guys. So later, okay, if I go and then I know, okay, partial fraction. Okay, cool. Now let's continue. So now that question is done. Now we go to question number 71. Question number 71. Man, I'm not supposed to raise the formula because this one also seems to be by parts. Okay, so you see, I just go confused a little bit. It started confused like a lame student. Come on now. Okay, no more confusion. Let's get it done. Okay, question number 71. 71, yeah, 71. This one seems also by parts, so integral of x squared and the sine pi x dx. By parts, if you have something with a sine or something with a ln, something with a sine, like angle or whatever with a trig. You see, ln with something with a sine, like integral. That's how you do by part. If there's a trig with, let's say something with a trig or something with a ln, and then you know that's a by parts or inverse of trig. So now let's come for this. Oh, this by part too, because the structure say here, right? X squared and sine of something. So the formula we know. Okay, so I'll just start with u. What is a u? U equal to x squared, and then dv equal to sine pi x. Okay, now differentiate this du equal to 2x, and then v, when you integrate here, you get v, and then when you integrate this going to be 1, and then what you do, you differentiate this pi x, which is going to give you pi. You see? It's going to give you pi, and then you see, when you integrate sine, you get negative cos. So it's going to be negative cos pi x. So we have everything. So now we're going to say, substitute in the formula. This one equal to uv. U times v means take this one multiplied by that. So we have a negative x squared, and the remainder cos pi x over pi minus v. What is my v? My v, this one right here. This is a constant. So I'm going to say v equal to negative. It's going to come out, it's going to be positive. So you got cos pi x. This pi is underneath, but pi is constant, so it's going to go to the back. So 1 over pi, and then multiply by du, 2x. So all this multiplied by 2x. So I can write 2x here. Before, I prefer write 2x, and then that one follow. Okay, 2x. So rather write 2x, and then I can write cos pi x. Okay, cool. This one went back, and this negative became positive. So we have this dx. But even this one also is the constant. Hold on, face. Hold on. No. 2x. So du is 2x. Okay, du. Okay, again. Du. Because let's say integral v du. V. What is a v? V. This one here. Negative cos. Take back. Negative in pi. Negative pi. Remember. So pi cos x. And then time du. Du equal to 2x. 2x dx. 2x dx. 2x dx. But 2 can go to the back. But this one alone itself is another by part. So all of this, which is x squared sine of pi x dx, it gives us and then we got another by part. So let's do this by parts separately. So we say tag. Okay, so we got integral x. So let me do this. This could be our style question. And then I'll come back here. Okay, so I can say, okay, let me do straight away u. What is our u? U equal to x, and dv equal to cos pi x dx. Okay, differentiate du equal to dx, and then when you integrate the v, when you integrate this, you get 1 over pi, and then this is going to give us sine pi x. Okay, so now let's put together, put in the formula. Let me just put here quickly, okay? Okay, so I'm gonna say plug in the formula. Okay, let's come here. Okay, all this stuff here equal, or let me just say this integral of what of x cos pi x dx equal to uv x over pi sine x. Okay, so it's gonna be x over pi sine x sine pi x minus minus integral v. What is a v? V 1 over pi. So it's going to go to the back. So 1 over pi. Okay. Sine x. Okay, right. Pi x. Okay. Times du. What is it? Du equal dx. Dx. Okay. So here we can simplify because now this is going to give us equal to pi x over pi sine pi x, which is this one. We rewrote it 1 over pi. Okay, now let's integrate that. So when you integrate that, it's going to give us, when you integrate pi, because you have to differentiate whatever we have there, which is going to give us pi. And then when you integrate sign, you get negative cos. Negative positive is going to be cos pi x. Okay, so now we're going to take this and then substitute back here. You see what I'm saying? So if you substitute back, so this is going to become, okay, so it's going to become, let me use a red pen quickly. So it's going to become, okay, let's just take this 2 over pi and then put it in there. 2 over pi, put it in there. So it's going to be, I can just take and put it in here. Or if you, okay, let's put it in, because at the end of the day, I'm the one who got to do for you. I have to do for you. Okay, now let's go. So it's going to be pi x negative. Let me write here. Okay, so this is equal to negative x squared. Let me see if I don't want to write under the whiteboard. Yeah, it's written right there. Okay, so this is going to be equal to negative x, okay, cos pi x over pi, and then minus. Now 2 times x is 2x. Pi times pi squared. Or I can take all those pi out. I think the best way to take the pi's out. So it means I'm going to take, we have a pi and pi, they can go out. So this is going to be pi squared. So I can just say 2 pi squared. You see what I'm saying? And then this stuff right here is there. So say x sine pi x, and then plus, remember, took pi and pi out, so it's going to be cos, only 1 pi at the bottom, right? So this 1 over pi, so cos pi x. So this is going to be our final answer. Okay, do you have a limit? You don't have a limit? No limit. So since there's no limit, so we can just plug c constant. And that's the end of this question. You understand what I'm saying? Now, let's go to the next question. Which is question number, which one did I do now? Sin x. I think I did this. I believe so. Yeah. So now we go to question number 73. Question number 73. Until morning time. See, the sunrise is almost there.
Basically almost everything.
And there we go to advance. Okay, well, thanks a lot. Thanks for time, Melissa. Thanks a lot. Appreciate. Peace and love. Peace and love. Peace. 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 Thanks a lot. Thanks, Melissa. My queen, you gon' wait me till Jesus come. Why when I talk, pocket full floss, money, honey, forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer.